We got several things to do in this problem. The first thing to do is to find the unit tangent vector, which is right over here. Vector t of t equals to the derivative of vector r divided by the magnitude of the derivative. And then we find the normal tangent vector n of t, which is equals to the derivative of capital T of t, the unit tangent vector, divided by the magnitude of its derivative. And then after this, we will be using this result to find the curvature using this formula. So this looks like a k of t, but the k, we use a Greek letter. The Greek letter is called kappa. Just say k, which is k. So k of t, this k means kappa, the Greek letter, and then that the curvature is equals to the magnitude of the derivative of the unit tangent vector divided by the derivative of r of t. So what is magnitude? Magnitude, an easier way to define the word magnitude is a curved surface deviates from a plane. So here is how I picture this. So imagine you have a piece of paper on your table. So the piece of paper is lying on your table flat, right? And then you grab a corner and then grab a corner of the paper and then start waving the paper. So can you imagine that you are trying to create some curve? So the paper was a surface, was flat, right? You grab a corner, start waving it. So now you see some curve. That is curvature. Okay, back to this problem. First of all, we have to find the unit tangent vector. Okay, everything is color coded. So let's get started. So we have a r of t equals to t squared, comma, sine of t minus t cosine of t, comma, cosine of t plus t times sine of t, and I want t to be greater than 0. Okay, so the first step is you will have to find r prime of t, right? So according to this formula, you have to find r prime of t, and then you find the magnitude of that, and then you divide them. Okay, r prime of t, so let's do it. So r prime of t, the derivative of t squared is equals to 2t, and then the derivative of sine is cosine, and then this one we have a product rule, right? So we have a product rule is fg prime plus gf prime. So we have to write t, the derivative of cosine is negative sine, and then plus cosine of t, the derivative of t is equals to 1. Okay, so this is done, and then comma, cosine derivative is negative sine, and then plus another product rule, the derivative of sine is equals to cosine, so we have t cosine of t, and then plus sine of t, the derivative of t is equals to 1, and then that's it. And then let's clean this up a little bit. So we have a 2t, and then what is in the next component? The next component, we have a cosine of t minus cosine of t, right? So the cosine of t is gone. Then we have a positive t times sine of t. And then last but not least, we have negative t plus sine t, that is gone. And then you have a comma, t cosine of t. All right, so that is the derivative of vector r. Let's find the magnitude. Magnitude means we square every single component, add them up, and then take the square root of that. So we have a square root, and then inside the square root, we square every single component. 2t squared plus t times sine of t squared, and then plus t cosine of t, and that one is a square. And then what is that equal to? That one gives you a 4t squared, and then plus t squared. Okay, do you see that the next two terms, they both have a t squared? I will just factor out a t squared, and then I have sine square of t plus cosine square of t, that is equals to 1. And then this is equals to the square root of 4t squared plus t squared times 1, right? And then that one is a 5t squared. And then take the square root of that. We have square root of 5t. So that is the magnitude. And then now we are ready to find the unit tangent vector by taking the derivative divided by the magnitude. So the magnitude, since that is something divided by that, so I can just take that out and then put that in front. And then the r prime. The r prime is right over here. So we have a 2t, comma, t sine of t, comma, t cosine of t. It is just like having this in the numerator, right? It is the same thing as putting this in the numerator and then divided by the magnitude. So that one, all you have to do is you distribute the 1 over t. So once you distribute the 1 over t, you have 1 over square root of phi. 2t divided by t is 2. And then sine of t divided by t, you have sine of t. And then you have cosine of t. So what is this result? This is a unit tangent vector. So this is a unit tangent vector, which is capital T of t. All right. So next thing, using the unit tangent vector, we can find the normal tangent vector, because look at the blue formula. In order to find the normal tangent vector, we will need the unit tangent vector. So now we are taking the derivative of the unit tangent vector. We match the color code first. So the derivative of that is equals to the constant. The constant stays outside, so we don't need to take care of the constant. And then the derivative of 2 is equals to 0. The derivative of sine is equals to cosine. So we write cosine of t. And then the derivative of cosine is negative sine of t. So the derivative is done. And then what is the next step? The next step is you find the magnitude. All right, so when you find the magnitude, the 1 over square root of phi, you can keep that outside. And then the rest goes inside a square root. You square everything, 0 square plus cosine of t square, and then plus negative sine of t square. Okay, what is that equal to? That is equals to cosine square plus sine square is equals to 1, right? So that means inside the square root you have a 1. Then overall that is 1 over square root of phi. So this is the magnitude, and then that becomes what is this? So look at the blue formula above. You have the derivative divided by the magnitude. So the magnitude is 1 over square root of phi, and then the derivative is 1 over square root of phi, and then you multiply 0 cosine of t, and then times negative sine of t. The numbers are so nice because we can just get rid of the fraction, right? Do you see this? We can just get rid of the fraction. So after you get rid of the fraction, what do you get? You have 0 cosine and then negative sine of t. So now we can get to the curvature. So the curvature, this is a K, but again, that is they use a Greek letter called kappa. That is equals to the what? The magnitude of what? The capital T, the magnitude of the unit tangent vector divided by the magnitude of r prime of t. So what that equals to is the t prime of t. So that is right over here. That is the 1 over square root of phi. So let's match the color code. So this is 1 over square root of phi. So how about r prime of t? R prime of t is right over here in orange. Right over here. Follow my cursor. That is square root of phi times t. All right, so that is square root of phi times t. So this becomes 1 divided by root phi times root phi t, which is 1 over phi t. So that is the curvature. All right, so that is the end of this problem. If you like the way I explain unit tangent vector, unit normal vector, and curvature, give this video a thumbs up. If this is something that you want to see in your future math classes, subscribe to my channel for more content. As always, I will see you all in the next video. Signing out.